class, what did we see? What did we talk about last class? Polymorphism, interface. Did we see the abstract class? No. Okay. So my question now: what is abstract class? Some of you might have gone through the contents of the week. What is abstract class?
We discussed about the abstract, but we didn't do any hands-on.
Okay. Awesome. So what is abstract class?
The abstract class is a class that's we don't instantiate it. It just gives it as a reference to other subclasses.
It's like a model class.
Anything else? What is abstract class? Anything else you want to add? We cannot instantiate it. It's like a model class,
Highest level class.
highest level. Now my question is here is that if I cannot instantiate the class like type, so why are we creating it in the very first place? Is it actually required? Because so far we did programming, right? We created so many programs and we never created any abstract class, correct? So is it actually required to create an abstract class? Is it actually necessary? Sometimes. Can you give me situations when it is necessary?
So when we don't know the user what's going to do at the time, for example, we have a draw method. We don't know which kind of draw user going to choose.
Draw.
Draw.
Okay.
For example,
Draw method we have.
yeah, and we don't know so the user which object we're gonna draw. So at the runtime, so we can use the abstract class.
Excellent. So suppose there is shape class and it has a draw method, right? But shape class is inheriting suppose this line and we are inheriting shape there, and maybe the circle, right? We are inheriting shape, so extending shape, right? So the draw method, it's just generalized draw, right? It is not specifying how do we draw a line, how do we draw a circle, right? This draw method from the line class is going to specify how do you actually draw the line, or how do we actually draw the circle. So there is some functionality which is fixed for the shape. For example, shape might have some kind of dimension, like it's a 2-dimension or 3-dimension or what exactly it is, right? Shape might have its color, right? It might have some attributes, it might have some methods. Some of the methods might be common and some of the methods might be just specific for specific classes, right? So some of the functionality which are general, you can define that inside the abstract class. Let's take another example. Okay? For example, there is an animal abstract class. And there is elephant and cheetah. I think last class I gave this example, right? So suppose the animal has number of legs. Okay? And these number of legs are 4. Okay? And that is common or general feature for the animal like elephant or cheetah. Right? So this classes, they have some functionality which is in common, and there is some functionality like move, which is generalized because they are gonna move. But how far they are gonna move or how the move is gonna react, that is not specified because elephant might move by 4 steps and cheetah might move by 40 steps. So how far they are gonna move is gonna be defined by this subclasses. So this is the scenario where you will use abstract class. So some of the functionality which are general is defined here, and whatever is specific is defined here. Now the question comes here is that can we use an interface here instead of abstract class? No?
Instead of the 4 legs? Yeah, for 4 legs. It's for
Yes.
moving.
So if I don't have number of legs that equals 4 and just there is just move method, so I can use interface in this case, right? So when to use interface and when to use abstract class is up to the software designer. But usually interface is used whenever there is common behavior or common contract or common promise that needs to be fulfilled by the subclasses implementing the interface. For example, if there is operating system, right, and it's gonna perform some operations on the task. So there are some tasks T1, T2 and T3. So all the tasks are gonna perform some common behaviors, like there will be start, there will be process, there will be stop, and suppose there will be wait. Okay, so these are common behaviors which will be performed by all the tasks. But there is no commonality between these tasks. Suppose the task is, backup. So this task is doing the backup. This task is doing the scan, virus scan, and this task is showing the presentation. Okay, so all of them might start, might process, might stop. This might process in a different way than this one. The internal implementation of each of the methods might be different, right? And this presentation might have a different processing. But all the tasks are gonna follow these common methods or are gonna implement these common methods. But what is inside is gonna be different, right? But every task needs to follow this contract or this promise. So that is nothing but your interface. Clear? Any questions? Yes?
Is it possible to mix the abstract interface?
Okay, is it possible to mix? Why do you want to mix it?
So some of the subclasses can have use one interface from another class.
Give me an example when you want to mix that. Can you give me exact example what you want to do?
Not really sure, but for
So
example,
you want to use
we have-
interface inside abstract class. That's what you are saying.
yeah, for subclasses.
For subclasses.
For
So you want to create an abstract class. Should I name this as base class? And inside here you'll create some methods. Method 1, method 2. So these are methods from interface. That's what is your concern. Is this your question or what is your question?
So I'm asking the general question, is it possible or not? For example, we have so we need to use some common, for example, method from another classes.
Sorry?
We have to use common method from other classes.
So, if suppose there is method 1 and method 2 in another class, and you want to use it inside this class, which is abstract, this class is abstract or that class is abstract?
No, this class.
This class is abstract. You want to use the class 1's, which is a concrete class, right? The methods of this class, M1 and M2 suppose. You want to use them inside your this abstract class. That's what your question is, right? So what you can do?
And call the method from that class.
How? So yeah, we'll try that out. We'll get the functionality of a class inside an abstract class. But usually this is not why the abstract classes are meant for. But since there is a question, we'll try it out, okay? So I'm going to create a new project to try out. I'll name the project as week 6 demo and click on next and finish. Don't create. Now I'm going to create a new class. Okay, I will name the class as test1 and I will add a main here. Should I add? Oh no, let me add a main. If I don't need it, I can comment it out. Okay, so here are two methods, public void m1. There's nothing going on inside here, just for testing purposes. Public void m2, correct? So you want these two methods and you want to create an abstract class. So I'll create a new class. I will name this as test2 and I'll make this class as an abstract class. So I'll just check in this check mark and I'll click on finish. Now I want to get the functionality of these classes inside this abstract method. So what I can do? Can I use extends? Can I use this?
Maybe so.
Mhm.
Maybe it's not the subclass of that class.
This is subclass,
There are two different classes.
two different classes. Then you want to use,
So the main, my question was then we should use the interface in that situation or not?
So I didn't get your question. Can you repeat that?
So for interface, we use the common behavior from another class to add it to another class, right? Is it interface or not?
Okay. So let's create an interface first. New interface. Okay. I'll name this interface as animal. Even though it's not, but I'm going to just make it an animal interface. Okay. I'm going to keep this inside default package. Okay. Now there's a method which is public void move. Okay. So there is this interface and now test1 is implementing animal interface. Implements animal. Okay. Now since this class is implementing animal interface, there is no error. There is no error. But same thing, if I am implementing here the animal interface, implements animal interface. So it's an error. Why? So let's see the error first. What is the error? It's saying the type test1 must implement the inherited abstract method which is animal.move. So the animal.move here, this is the method, right? It's defined but it's not implemented, correct? So in test2, here even though it is not implemented, but there is no error
It's abstract.
because it is an abstract. So in abstract class, it does not expect that everything should be defined and implemented. Whereas in concrete class, it wants everything to be defined and implemented. So it's giving us an error. So let's try to add the unimplemented method, which is move. So once it added this move method, it's good. There is no problem. Okay? So something that is common, you just define that functionality. You don't define the implementation in the interface. Interface does not have any implementation. Okay? Now is your question clear? Okay. Now we'll look at how we saw the polymorphism, wherein you are creating an object of base class and instantiating that to the subclass, right, or derived class, and then you are calling the same method and you are trying to see which method is called. Is it subclasses method or is it superclasses method, right? So let me just get back to the same thing that we did last class so that you are in link with what we did. Section 4.
Yeah.
Yeah, so here is our program which we saw last session. So there was this base plus commission employee which was extending commission employee, right? We saw this commission employee first. We created these instance variables, getter, setters, constructor, toString, and then we use the inheritance concept, extends this. We saw there were duplicates, so we did the inheritance and we added just the base salary there, and we validated through an exception if it was not valid value, right? Now we'll try to test it out. So I'm going to create a new class here. I'm going to name this class as test. And I'm going to add a void main here, and I'm going to click on finish. Okay, so what I'm going to do is I'm going to create an instance of commission employee. I'll name this employee's number as E1 equals new commission employee. I will name the employee's name as Igor. Igor, your last name? Sorry, can you spell it? S-H-A-D-B A-L-K-I-N. Social security number, so I'm going to put it 1111, and then I'm going to place the gross sales as 20,000 and commission rate as 0.06. Okay, so yeah, this is how you create an instance of an object of class, right? Now what if I am trying to call the toString E1 dot toString. Okay, I'm calling the toString for E1. Now what it should do is it should call the toString for commission employees, correct? So toString is called, which displays the name, social security security number, gross sales, and commission rate. So everything is working so far good, right? Any questions so far? We are on track?
Can I just ask you, where you got the folder lesson 6/12/16?
Okay, so this is available right here in your weekly contents. So these are student files for student in week 6, and here is the example. Okay? Now, what I'm going to do is, I'm going to create another employee. Okay? And this employee is base salary plus commission employee. I'll name this object as E2 equals new base plus commission. This time I'm going to add your name, Ryan. Ryan, and last name
TSANG.
TSANG. And I'm going to add social security number. I'm going to make it 222. And I'm going to make the gross sales as 2,000. And I'm going to make the commission rate as 0.06. 05 maybe. And I'm going to make a base salary of $1,000. Okay. Now the employee 2 is created. Now same thing I'm going to do. I'm going to call the toString for base plus commission employee for E2. And I'm going to run this. So this time you can see first one is commission based employee. Igor is commission based employee, and his details are printed. So he does not have a base salary, so base salary is not printed. Whereas Rayan has, base salary, so his base salary is printed as well, right? So our toString in base plus commission has base salary printed as well with the supers toString. So our program is working good. It is calling the toString of base. This is calling the toString of derived. That's what we want. Everything is going good so far, right? And likewise, if I say, instead of toString, if I say calculate the earnings of Igor, and I say earnings of Rayan, okay, so it's gonna do it for us. Let's see if it does. Yeah, so it's calculating the earnings of both of the students. Okay, now let's try to create an employee which is employee 3, and this time we are gonna make a different employee. Okay, now I will add Parth till last name.
Sharma.
And I will add the SIN number, and I will add gross sales. I will add the commission rate, and I will keep the base salary, and this is good. Okay, now I will add same thing for earnings. E3 dot earnings. This we did last class. So even though this is an instance of base class, right? But it is calling the earnings of base plus commission employee. So in simple terms, you'll see that all of them are calculating the earnings depending on the employee type. The third one is base plus commission employee. So it's calculating the base plus commission employee's salary, earnings, right? Any questions so far? Now my question here is, this is polymorphism. So even though I'm saying for employee E1, calculate the earnings, it is calculating the earnings. Employee E2, it's I'm saying that calculate the earnings, it's calculating the earnings, employee E3, calculate the earnings, and it's calculating the earnings, right? My question here is, what's the use of this polymorphism? I could directly, create an instance of this E1, and I was directly calling earnings, and it called the earnings. So what if I kept earnings 1, earnings 2? Or what's the use of this polymorphism?
So it could be the same collection. Or just
Excellent. Yeah. So that is very important. Suppose I create an array of commission employee. So, or maybe list of commission employee. You guys are familiar with list? We'll look at list in week 12 as well. So I'm going to just now create a list of just list interface. So I'm going to create a list. Maybe I'm going to create an array. So commission employee A1 So you can see if I created a collection or an array of employees, okay? I'm just saying one thing, just print that employee, or I'll call the toString dot toString. Okay? So if it's a commission based employee, it's automatically gonna print everything related to commission based employee. If it's a base plus commission based employee, let me comment this out. So if it's a base plus commission employee, it's gonna print the base plus commission employees details. So let's see. So first, our commission employee Igor, his values, his data is printed. Then we created base plus commission employee Brian, and his base plus commission salary is printed. Base salary is there for Ryan, so base salary is printed. Whereas, okay, I forgot to make it equals, so part salary is not printed. Now hopefully part salary will be printed. So part salary with base salary is printed because he's also base plus commission employee, right? Now what I'm doing, I'm giving a common command like toString or maybe earnings. Okay, I just said earnings, and it's going to calculate the earnings for the employee. Now it's going to calculate the earnings depending on the employee type. So if the employee is a commission based employee, it's going to calculate his salary based on commission. If the employee is base plus commission based employee, his salary will be computed like base plus commission employee salary, right? So I'm giving the same message. Depending on the reference, it is calculating the salary of that employee, right? So this is the beauty of polymorphism. Now polymorphism is of two types. what is compile time polymorphism? Any idea? So in assignment 1, sorry, excellent. So in assignment 1, you did method overriding, right? So you had the method add. With one argument, it's going to add one number. If you have add with two numbers, 1, 2, it's going to call the method to add the two numbers, right? If you have add 1, 2, and 3, so it's going to call the method with 3 arguments. So at the compile time, the number of arguments will be passed, and that is going to decide which method needs to be called, right? So this is compile time polymorphism, because at the compile time it will know what exactly needs to be called. Let's consider the operator overload. So consider the operator plus. Okay? So in case of plus operator or the addition operator, if I'm saying 1 plus 2, what it is doing? It is adding 1 plus 2, and the resultant is 3. Whereas if I say s plus a, what is happening? You guys can see the board? Are you able to see the board? Yes, right? Okay. So if I say s plus a, so it's going to concatenate them, right? So there will be SA, which is print, right? So what is the operand is going to decide what operation is done. So if the operand is string, it's going to concatenate. If the operand is integer, it's going to do the addition, right? So this is compile time, again polymorphism, right? Same thing, it's taking different forms depending on components which are decided at compile time. This is the dynamic binding that we are doing is an example of runtime polymorphism, right? At the runtime, it is checking if the base plus commission employee has the reference of base plus commission or it has the reference for commission employee. So if I do something wrong here, for example, I create an instance of commission employee E4 equals new I will write his name, Marco. Sorry. What is your name? I forgot your name.
Elijah.
What is your last name, Elijah?
A-B-R-A.
A-B-R-A.
Z-A.
Z?
Yeah.
Now, if I try to call P3 dot earnings, right? There is no error. But if I try to typecast this to base plus commission, okay? So this one, I'm trying to typecast this to base plus commission. So it's giving me an error saying that this cannot be instantiated. So if I say type a cast, add a cast, so this is added a type cast, but when it's executing this method, let's see what method it's gonna call. So it's giving me an exception. So if something was wrong, usually it showed as a red line, but here it came out in a red in the console. This is because it is runtime error. because this dynamic binding is done at runtime. So when it's running, it is getting this exception on line 13, wherein it's trying to typecast commission employee reference to base plus commission employee, wherein the base salary is not specified. So how can it convert it to the other way, right? If it was an instance of base plus commission, it could convert that to commission employee, but base salary is not specified here, so it is not able to convert it. So this it identifies at runtime, and so it's giving an error at runtime. Okay, so difference between compile time polymorphism and runtime polymorphism is clear. Any questions regarding the same? Everything's clear? Yes, Ali?
So we can have like abstract if polymorphism, because it's like at the runtime we can choose which method it's gonna be issued.
Yes, abstract method variables can be created for polymorphism. Just like what I did here is I created a commission employee E1, right? So I can create a like abstract, or if suppose I had abstract class called employee, I could create E1 1, and then I can say new commission employee. I can do this. Okay, so actually abstract class or interface or the base class, all of them or any of them can be used to achieve this polymorphism. Okay, yeah, any other questions? Good. Okay, let's move on.
I had a question.
Yes, please, Vinay.
The polymorphic screen manager.
Okay. So polymorphic screen manager. So polymorphism is what? You are gonna call the same method. Okay. So what your polymorphic screen manager is gonna do is you're gonna call the same method, but for life insurance, it's gonna give a different screen, wherein it might take, the life insurance related details. When you call the same method for health insurance, it's gonna give a different screen. So like our Sentinel software, right? When you log in as a student, you might get as a different screen as compared to an admin or a counselor, right? Counselor might be able to get student's profile, but a student might not be able to get the student's profile, right? So what you're gonna do in polymorphic screen manager is you'll call the same method or you'll perform the same task, and you should get a different screen for different call. So if you are creating an instance of life insurance, it should show a different screen. If you're creating an instance of health insurance, it should show a different screen. Does that make sense?
Is that like a pop-up window? Is that in the output for console?
Pop-up window. I would recommend doing it in pop-up window,
J option.
the option pane. Okay? Anything else? So it's just creating a J option pane similar to what you did in previous assignments or previous classes, just that for life insurance you might have a different number of options in J option pane, whereas for health insurance you might have different number of options. Okay? Yes, any other questions? Everything's good so far? Okay. So let's move on to the next example. Now here, there is an abstract class employee. Okay? So our same program we're gonna look at, just that we will have some more additions there. So let me just open the presentation and I will show the hierarchy, and then we'll move on to program. this is the case study that we will learn about. Using abstract method and polymorphism to perform payroll calculations. So suppose you are given an task to calculate the payroll of employees of Centennial College. Okay. Now Centennial College has different kinds of employees. Okay. The employees are of 4 types. First is salaried employees. They are paid fixed weekly salaries, regardless of how many hours they have worked. So these are first kinds of employees. Okay. So their salary is fixed, no modification whatsoever. Right. Second kind of group. Just release this. Second group of employees are hourly employees who are paid based on hours they have worked. Okay, so we'll compute the number of hours times the fixed rate or the salary, hourly salary, and if they have done some overtime, so that will be computed as times the hourly hours they have worked times 1.5. Okay, so it would be paid 1.5 times their salary, right? And there is commission employee who's paid percentage of their sales, right? Sales times the commission rate. You'll multiply that and that will be paid for the commission employees. And finally there is base salaried commission employees who receive base salary plus the commission that they earn depending on the gross sales and the commission rate, just like commission based employees. Now for the current pay period, the company has decided to reward salaries commission employees by adding 10% to their base salaries. The company wants you to write a Java application that performs its payroll. Can you try to write this program? Do you think you will be able to write this program? Or what is the hierarchy you will think about in this program? What will you use? Now, first thing, if I am a new programmer, I don't know what abstract class is, what an interface is, I am going to maybe create class for salaried employees or fixed salary employee. I'll create a class for hourly employee, and I will create a class for commission based employee, and I'll create a class for base salaried plus commission based employee, right? And then what I will do is I'll create a generalized employee class which has all the fields, right? And then I will create some methods inside these classes, which is all of these classes, and there I'll compute the earnings, right? So is there any issue in that? No issue, right? Just the problem will be, if suppose there is some common functionality which might be modified, I might have to, rectify it at some places. And also, the main drawback here would be, when you are trying to create an instance of an abstract class, right? So that instantiation will not be possible, but when you are trying to create an instance of employee, that will be possible, right? But other than that, what is there in abstraction is that, you cannot decide as to what the earnings of employee will be. Okay, so you might not be able to create an earnings method inside the employee, right? And if you create an employee instance, then you won't be able to get dot earnings because that is not defined inside that class, right? So polymorphism will not be possible using that kind of class approach. So let's create this this employee as an abstract class. Okay, so if I create this employee as an abstract class, so I'll write that in italic. Okay, and now what all classes will I have as the classes which are extending the employee class? So what are the types of employees? There are fixed salary employees, correct? So I'll create a class for fixed salary. Next, what is the other type of employee? Hourly employee. And next, commission based employee. Now there is one more, so I can create that as a base class for this one, just like we did in the previous example, right? There is base plus commission employee. Correct? Same thing. Now, what you're doing here is just the hierarchy is changed. Now, employee class will have an abstract method for earnings or for calculate salary. Correct? Now let's see the actual case study. So there is abstract class employee, which represents general concept of employee. These are the subclasses. This is the inheritance, right? We created similar kind of class design. Now the abstract class, superclass employee declares the interface to the hierarchy. That is, set of methods that a program can invoke on all employee objects. Now, this interface is different from the interface that we are learning. So don't confuse this with the interface. So interface is, it's referring to various ways programs can communicate with objects of employee subclass, right? So each employee has first name, last name, social security number defined in abstract superclass employee. The class provides earnings method and toString method in addition to getter and setter that manipulates employees' instance variables. An earnings method applies to all employees, but each earnings calculation depends on employees class. So all the classes are going to have employee earnings method, but how it's calculating the earnings is dependent on the type of employee. So hourly employees earnings will be calculated depending on number of hours worked into the fixed salary, which is hourly salary for the employee, and if it's greater than 40, then you're gonna give 1.5 times the salary, right? Iterate through the array of employees and call the method earnings for each employee subclass object. Method calls process polymorphically. Just now we saw how commission employee, we created an array of commission employee, and how polymorphically it called the toString, it called the earnings, and it calculated the earnings for that particular type of employee, right? Now this diagram shows each of the 5 classes in the hierarchy down the left side, and methods, earnings, and toString across the top. For each class, the diagram shows the desired result of each method. Declaring the earnings method abstract indicates that each concrete subclass must provide an appropriate earnings implementation, and that a program will be able to use superclass employee variables to invoke method earnings polymorphically for any type of employee. Now here is the actual method earnings and toString. So if it's an employee, So this earnings method will be abstract because we don't know how much or how to calculate the earnings for an abstract employee. So this method is kept abstract. Now this toString will print first name, last name, social security number for the employee. Now if the employee is salaried, so you are gonna give a fixed weekly salary, right? And you'll also print in toString all the salaried employees first name, last name, social security number, weekly salary. If it's an hourly employee, your earning method logic should be something similar. If hours is less than equals 40, then wage will be wage times hour, which will be written. Otherwise, if hours is greater than 40, so 40 times wage plus hours minus 40 times wage times 1.5. So this is time and half for overtime, right? And if employee is commission-based employee, which we did in the base class, you just multiply the commission rate with gross sales, and that will be the earnings of a commission-based employee. If the employee is base salary plus commission employee, then there should be a base salary that is added to this commission rate times gross sales. Correct? So toString is gonna be similar. Just the difference is that if the employee is commission-based employee, so there will be gross sales and commission rate which will be declared and shown. Whereas if the employee is hourly employee, so hourly wage and hours worked will be shown. If the employee is commission-based employee plus base salary, so both of them with gross sales will be shown, right? Now this is again payroll example continued. So this is abstract superclass, which is employee, and other classes or subclasses are concrete. Now figure creates an object of each of the 4 concrete class, manipulates this objects non-polymorphically using the variables of object's own type, then polymorphically using an array of employee variables. While processing the objects polymorphically, the program increases the base salary of each base plus commission employee by 10, requires determining the object's type at execution time. Finally, the program polymorphically determines and outputs the type of each object in the employee array. So all call to the methods toString and earnings are resolved at execution time. So we are gonna find which is the instance inside that particular object or variable, and based on that object type, it's gonna call that particular method. So this is called dynamic binding or late binding, and Java decides it at execution time rather than compile time. And a superclass's reference is used to invoke methods or classes or members of superclass, and the subclass method implementations are invoked polymorphically. So depends on the reference, it's gonna call that particular method from the subclass. Attempting to invoke a subclass only method directly on a superclass reference is a compilation error. This we tried to invoke a subclass only method on a superclass reference, and we got an error. Now there is for polymorphic processing, operator, instance of, and downcast. So every object should know what its class is, and it can get its information using getClass method. Okay, and this method is available from the object class, which is at the top of the hierarchy. So if you want to know what is the class of that particular object, you just call the .getClass method. Now this returns an object of type class which contains information about object's type, including its class name. The result of getClass is used to invoke getName to get the object's class name. Now you will use the getClass and getName and compare them if they are of the same type. There are three proper ways to assign superclass and subclass references to variables of superclass and subclass type. Now, assigning a superclass reference to a superclass variable. This is simple. We have done this so many times. Assigning a subclass reference to a subclass variable. This also we have done a lot of times. Assigning a subclass reference to a superclass variable is safe because the subclass object is an object of superclass. Now the superclass variables can be used to refer to only superclass members. If this code refers to subclass only members through the superclass variables, the compiler reports the errors. And when we try to typecast that or cast that, it's gonna give class cast exception at runtime, right? Now the final methods and classes. What is final method?
Cannot be overridden.
Cannot be
Overridden. You cannot
overridden.
override.
Okay, awesome. So when can we initialize this final members?
When you don't want to change.
Excellent. So you need to give that final variable some value, right? When can we initialize that value to the final variable? Can we give it in main? No.
No.
So where can we give it or initialize that final variable?
In the class.
Yes, in the class, in the first statement where it is declared, that's one option. Second option, if I don't want to declare it there, then where can I give it?
Constructor.
Excellent, in the constructor. So I can even initialize that in the constructor. A final method in a superclass cannot be overridden in a subclass. So if you declare a method as a final in a superclass, you cannot override that in the subclass. So if our earnings method was final, so we could not create an earnings or override that earnings method in the class which was base plus commission employee, right? Methods that are declared private are implicitly final because it is not possible to override them in a subclass. So if you declare any method as private, so obviously you cannot override that. Again, methods that are declared static are also implicitly final. A final method's declaration can never change. So all subclasses use the same method implementation and calls to final methods are resolved at compile time. This is called static binding. Now final or static or private, these three kinds of members, they are all final, they cannot be overridden. So these kind of methods, if they are called, the compiler knows they are taken from the superclass. So that kind of binding is static binding because compiler knows at compile time itself which method needs to be called. So this is again an example of static binding. A final class cannot be extended to create a subclass. All methods in final class are implicitly final. Class string is an example of final class. So this is very important and many times this is asked in interviews. If you were allowed to create a subclass of string, objects of that subclass could be used wherever strings are expected. Okay, so if you were, if it was not a final class and you were allowed to create a subclass, so object of this subclass could be used wherever strings are expected. But this is final, so you cannot create a subclass. Since this string class cannot be extended, programs that use strings can rely on functionality of string objects as specified in the Java API. Right? So you create an object of string and you can call all the methods using that object, right? Making the class final also prevents programmers from creating subclasses that might bypass security restrictions. And for security reasons only, the class is kept final. Do not call overridable methods from constructor. Now this is very basic rule which is used when you are overriding method. So whenever you are overriding a method, for example earnings, so never ever call that earning method in the constructor. Okay, if you are doing that, so when you are creating a subclasses object, this could lead to an overridden method being called before the subclass object is fully initialized. So if you create an object of base plus commission, right, which by default calls the constructor of commission employee and then the constructor of base plus commission employee. Now when you are trying to call the earnings method inside the constructor, the subclasses object is not yet created, right? So it's trying to call this method which is not actually there. So it sometimes creates subtle but difficult to detect errors. So in that case you should try to avoid calling overridden methods inside the constructor. And our next example re-examines the payroll system, and now the company involved wishes to perform several accounting operations in a single accounts payable application, calculating earnings that must be paid to each employee. So our payroll, what it did is it calculated the salary for each employee. Now again the company client wants you to calculate the payment due on each of the several invoices, that is bills that is for goods purchased. Okay, now one more thing need to be added, which is payment, and both the operations have to do with obtaining some kind of payment amount. For employee, this is the employee's earning, and for invoice, this is nothing but the total cost of goods that is given on the invoice. So I think some of you are sleeping, so let me go back to the program. So this is what we were talking about. This is our payroll application, which is we created this employee, which is an abstract class. So employee is gonna have some fields like first name, last name, social security number, then there's constructor, there's getter, there's toString, and since there's no earnings that is fixed for the employee because it's an abstract, right? So this method is declared as an abstract, right? Then you'll create the first class, which is fixed salary employees pay. So salaried employee is the class that is created for the same. Fixed salary employees are going to have fixed salary. So weekly salary fixed. So weekly salary is declared. Everything is similar to employees constructor except for one more field that was added for weekly salary. You will call the super constructor if the weekly salary is less than 0.0. It's gonna throw new illegal argument exception saying that weekly salary must be greater than or equal to 0. So this is just validating. If the salary value is good, only then it's gonna allot this dot weekly salary equals weekly salary. And this is the setter for salary. It's gonna set the weekly salary, and this is getter for weekly salary, and this is toString which is overridden, and this is earnings which is overridden. What this earnings is gonna do is it's gonna get weekly salary, okay, and that will be returned from this method which is earnings method, right? Here we override the abstract method earnings from the employee, right? So it's just gonna return the weekly salary, which is fixed. No problem at all for fixed salaried employees. But what about hourly employee? So hourly employee will have two fields, wage and hours, right? And the constructor will set these values, checking them or validating them, right? Then setter is gonna set the values, getter is gonna get the values, set hours, get hours. Now here earnings. So earnings is doing the logic that we saw in the table. So if then get hours is less than equals 0, you'll calculate by multiplying wage with hours. Otherwise we'll multiply 40 with get wage plus get hours minus 40 times get wage times 1.5, that is time and half for any hours worked after 40 hours. And then toString, it's just calling the super, that is employees toString, to print all the basic information of the employee, and then get the hours and get the wage for the hourly employee. Likewise, commission based employee we have seen, so I'm not going to go there, but it's the same that we have done, except for first name and last name. So instead of first name and last name, you're just extending employee, which is an abstract class. Now there is payroll system test, wherein you try to create an instance of each type. So you created an instance of salaried employee, hourly employee, commission employee, base plus commission employee, and then you try to process employees individually, right? You try to calculate the earnings for salaried, hourly, commission employee. Now you create an array of employees. You will add these employees inside the array, and using the for each loop, right, you are trying to print the current employee, that is you are calling the toString, and if the current employee is an instance of base plus commission, then you are downcasting the employee reference to base plus commission, and then you will set the base salary 1.10 times the employee's base salary. So if it's a base salary based employee, then it's gonna downcast that, the employee, and it's gonna give 10% raise to that person's salary, and it's gonna give new base salary with 10% increase is whatever is the base salary of the employee. And you will also try to print current employee dot earnings after the bonus of 10% is added to the salary. Now get the type name of each object in employees array. So you are going to get the employee get class dot get name. Okay, so you will get the type of object in employees array and his name, right? So when I run this program, so these are some values. When we process the employees individually, the salaried employee earned $800. Karan, who was hourly employed, earned $670. Commission employee Sue Jones earned $600. Base salaried employee earned $500. When you process the same employees polymorphically, then same thing was done. in less number of steps, and the salary was calculated. And for base plus commission employee, so if the instance was of so you checked if current employee's instance of base plus commission employee, and if that was true, then you added 10% to the salary of the employee, and that time so at that time you just printed the base salary of the employee, which was 530 for this salary employee Bob Levi's, and his salary was base salary was 300, so 10% increase, it got to 330, and with the commission he earned 530. And this is how you're getting the name get class dot get name, and what exactly it is doing, returning the name of entity, that is class, interface, array, class, primitive, represented by this class object, right? So the name of this class is salaried employee, so he is of type salaried employee. So if I remove this get name, so what's happening? Still it's gonna be same, okay? So this is the name of the class. Get class is also giving the same thing. Get name is also giving the same thing.
So there's never a difference?
So what get name is doing is, it's just giving the string name of the class. So yeah, string name is already passed or given by get class. So you can see there is no difference between them. But whereas if I'm trying to get something else, there might be difference. I'm trying to get something else. Let's try out. So if I'm saying get package, so it's just giving the package name.
You
Right?
have to call the dot, you have to call the dot get class first, you can just explicitly use dot get package.
You have to call the get class first, that's what is your question. Okay, so if I want to not call get class, suppose I want to just get the name, okay, so can I do that? So I can get the employee's name. Let's see,
Yeah.
okay,
I think he was talking about just the package itself, get package.
okay. So dot get class or dot get package,
Yeah, like you wouldn't be able to just call it by itself, right?
dot get package?
Yes.
Okay, let's try. Dot get package, no. This class is not available.
So the get class is just for debug.
Get class is returning an object. So object is gonna, try to print an object, and it's gonna call the object's toString, which is, given inside, which is implemented. Since the toString is implemented, that's the reason you're able to see here. But sometimes if the two strings are not implemented, then you might have to use dot get name to get the exact name of the class.
So my question is, that, so in which situation we use the get class for debugging?
Yes, so suppose if you want to get the class name of the type of employee that you are, working out on. Because what we are doing is employees are all saved inside the array, right? We don't know what class the employee is of. If the employee is fixed salary or hourly salary or what kind of employee, right? So if I want to just get the type of employee, hourly employee, and I want to make the base salary for the employees as 15.50, which was recently updated. The base wage was updated, right? So I just have to get the class and update the wage of that class. That's it. I don't have to do anything else. Okay? Is it clear? Any questions? Everyone's good? Okay, so I want you to go through this class and then, let me complete the interfaces first, then we'll move on. So we have discussed about interface. So interfaces are something that have capability, which are, you are implementing or you are showing some common methods. Okay, these common methods are defined for unrelated classes. We saw some of the examples, and these are usually used for controls which are usually there on radio. So you can have volume, you can have a tuning, like you can set the frequency, right? So these are some common controls which every user should have, okay? And there will be internal components that will be designed for those controls, right? So any radio you buy, whichever company you buy, you will have these kind of controls. That is, there will be volume button and there will be a frequency tuner, right? Even though what is inside is different, how the company is making it is different, but the controls are the same, right? So interface are similar to that functionality, right? You are gonna have fixed number of operations that can be performed, like changing the stations, adjusting the volume, choosing between AM and FM, but the controls may be implemented in a different way. Like some might use push buttons, some might use dials, some might use voice commands, right? The interface specifies what operations a radio must permit users to perform, but does not specify how the operations are performed, right? So the manufacturer is free to, design his radio his way, right? A Java interface describes set of methods that can be called on an object. So you're just going to define the methods that can be called. And you're going to define that by using the keyword interface. And all the members must be public. And you may not specify any implementation details. Now here, I have already mentioned that no interfaces will have the functionality, or what needs to be done is never there inside the interfaces, right? But in advanced versions of Java, you will see that interface also has an implementation. That is, there is a body that is there inside the method. So when you see that kind of methods, you will be puzzled. And you will say that interface does not have methods or implementation. How come this interface has implementation, right? So in advanced versions of Java, implementations are possible inside the interfaces, right? In scenarios where the interface is declared or the method is declared as default. So default method can have an interface implementation inside the interface. Okay, so you want to give a default functionality for a particular method, so you can have an interface with implementation in that kind of scenarios. And all methods declared in an interface are implicitly public abstract methods. So even though you don't mention any abstract keyword, it is by default understood that it is public method, it is abstract method, and every method is implicitly public, static, and final. Okay? To use an interface, concrete class must implement that interface, and then once you implement, you have to make sure that all the methods or all the contract methods that are defined inside the interface, all of them are implemented inside the concrete class. If they are not, you have to make sure that that class is made abstract, right? So this is contract, like I will declare all the methods specified by the interface, or I will declare my class abstract. This is the contract. An interface is often used when disparate classes or unrelated classes need to share common methods and constants. Sometimes people use that animal as an interface for elephant or cheetah, right? Because they might think that elephant and cheetah are different kinds of animal, so maybe you can create an interface animal and implement that. Yeah, it is up to the program designer what he thinks, but usually in general case scenario, when classes are unrelated, that time interfaces are used to show common methods or constants that needs to be shared among these classes. Allow objects of unrelated classes to be processed polymorphically to the same method calls. You can create an interface that describes the desired functionality, then implement this interface in any class that requires that functionality. Just like public abstract classes, interfaces are also public type. They must be declared inside a file with the same name extension as the interface and .java extension. Now this is another example. Here we are trying to determine the payment for employees and invoices, right? Classes invoice and employee both represent things for which company must be able to calculate the payment amount. So both the classes implement the payable interface. So employee and invoice, they are not at all related, right? They are different classes or unrelated classes, but they both have the functionality of payment. So they are implementing the payable interface. Now you can define method like get payment amount on invoice and employee objects alike. So if you are saying get payment amount for employee, it's going to get the salary of the employee. If you will get payment amount on the invoice, it's going to get the payment that is due on the invoice, right? So both of them are going to have get payment amount. So this again enables polymorphic processing of payroll or invoices and employees payroll. There is UML, that is distinguishing interface. So you specify interface like this in the UML, and the UML expresses the relationship between a class and an interface through a realization. A class is set to realize or implement the methods of an interface. This is model realization as a dashed arrow with hollow arrowhead pointing from the implementing class to the interface. Now this is the hierarchy that is used. There is this payable interface, and there is employee and invoice. And employee is an abstract class, and invoice is a class that is implementing the payable interface. Now figure shows the declaration of interface. Payable interface are always public and abstract, so they do not need to be declared. They can have any number of methods, and they can contain final and static constants. Now class invoice. Java does not allow subclasses to inherit from more than one superclass, right? So multiple inheritance is not allowed, but it allows to inherit from one superclass and implement as many interfaces as it needs. So in case you want to implement multiple inheritance, you can do it using interface, right? So just you use implements first interface, comma second interface, and so on. Modifying the class employee to implement the interface payable. So you just say class employee, okay, implements payable, but employee does not provide a get payment method. So the class must be declared abstract. So it is already abstract class, so don't worry about that. But any concrete class that must, of the abstract class must implement this method to fulfill the contract, right? So since employee is inheriting the superclass contract to implement the get payment amount, and so this class, that is concrete class, should have this get payment amount method. So now we will modify the salaried employee that extends the employee and fulfill the contract to implement the payable method get payment amount. So this is the payable interface. It has a method called get payment amount. There is employee abstract class that we did in which we created in previous example, and there is invoice class, right? Now this is implementing payable. Employee class is also implementing payable, right? But because this is abstract class, so get payment is not there, so that's fine. But salaried employee, if it does not have a get payment, it's going to give an error. So instead of earnings, we created this method which is called get payment amount, and if we call this using the employees instance, so it's gonna calculate the earnings or payroll for the employee. Whereas for invoice, if the same method is called get payment amount, it's gonna get the quantity times price per item. So it's gonna calculate the price per item based on quantity times price per item, right? Now when you are testing this, you are creating an array of payable objects, right? And first payable object is an invoice, second payable object is again an invoice, third payable object is a salaried employee. Again there is salaried employee. Now both of them are processed polymorphically. Even though they are not related, there is payment that is associated with both of the scenarios. So you are generically getting the payments using this for each loop, okay? And you are making this a type of payable from payable objects, current payable dot toString and current payable dot get payment amount. So you'll get the toString. Using toString you'll print the details, and get payment amount you're gonna calculate the salary. So you can see that when they are processed polymorphically, invoices part number, quantity, price per item, and the payment due. Second invoices, part number, quantity, price per item, and payment due. This is employee, his payment due or his salary is this. This is again a payment that is due. This is again a salaried employee, so this payment is due to, her payment is due to, right? So same functionality but on different classes which might not be related, and it is performing the same task. So eventually you will get to know that how much Sentinel needs to pay to invoices plus employees, right? Yes, Karan?
So is that the
Notation for,
Like with the code, I've never seen that before. Like I've seen it, but I didn't understand it.
sorry, I didn't get you again.
So 925 for payable, credit payable,
Mhm.
coded payable objects, that's the notation for iterating specifically through objects in the class?
This is for each loop,
For each? Okay, that's
for
just
each
how it is.
loop in Java.
Okay,
Okay, so you use the type of variable.
yeah.
Okay, you specify the individual type, and this is the collection of type. Okay, and then you can use individual type, then dot. You can call the methods that are there inside payable. Okay,
You can use standard for example, I0 by length.
yeah, you can use that, but you don't know what is the size of this array. If you
But
do
we
know,
can run through the array like links and.
yeah, you can use that. Yeah, you can use I equals 0 to 4, and I plus plus. You can use that as well. That is fine. Okay. Anything else? Yes.
I have two questions.
Yes.
First, the interface class is abstract, right?
Interface class. Interface is interface. Class can be of two types: abstract or concrete. Okay. So something that is defined or declared as an interface just has the methods, not implementation. Okay. So it is defined for classes that are, unrelated, just like invoice and employee. They are not related in any way, but they are doing some common functionality. There is a pay. There is pay for invoice. There is pay for employee, right? So they are not related. So for these kind of scenarios, you can create interface.
So in this example, so the payable class is a interface, right?
Payable is an interface.
So we probably don't have anything in the payable interface, just,
It's just one method that is defined,
yeah.
and that method is giving a contract that if you are implementing payable, that means you have to get the payment, right? So something that is gonna be payable, you are gonna get the payment info for that. So if it's a employee, his salary will be known or will be returned. If it's a invoice, then the amount on that invoice will be returned. And when you say interface, you say interface only. Interface is not a class. It's not a class. Okay? Any other questions? Everything's good? I think Ali, you are still confused. Good?
I don't know why we should use the interface.
Okay. So suppose if I tell you the whiteboard, okay? Whiteboard should have writing ability, okay? So writing is the task that will be performed on the whiteboard, okay? Now I tell you to buy a whiteboard for me, okay? I did not tell you anything. You might get a small sized, whiteboard for me, or you can get a giant big whiteboard, right? So what is the task that is performed? That is writing, right? So this task might be performed on either of the boards, right? So these boards, even though they are not related, but the task that is done is writing. So employee and invoice, both of them are not related, but the task is to get the payment info, right? So that is what is interface. It's just defining what needs to be done. How it needs to be done is defined by the concrete classes that are implementing the interface. So if I tell all of the class to get whiteboard for me, you will decide on your own what size of whiteboard you are going to get, because I have not specified any whiteboard size, right? So like that, interface is going to give general picture as to what is expected, but the details are not specified. So concrete class will provide the details. Okay? So let me, before I forget, just a quick one. So I want you to try practicing the exam. I have shown you last class. how to access and how to get the hands-on exam, right? Okay, I don't have this.
How's it gonna be in hands-on?
In hands-on, it is gonna be similar to our, you know, sorry?
Commission?
It will be similar to the assignments. Okay?
But I mean, which one? Commission more, or, I don't know, insurance stuff?
No, it's not gonna be something that is already there. It's gonna be something.
No, I mean, closer really.
It's gonna be related to the assignments, the way your assignments are.
All the 3 assignments are
Yes, that's correct. So if you are able to do the assignments, you should be, you know, able to do the exam, midterm hands-on. So what I'm going to do is, on Monday we have our class, correct?
Yes.
So Monday will be our hands-on exam. Seong is there? Absent? Seong is here, right? Alex? Absent? Monday will be our hands-on exam, and on Thursday is multiple choice questions. So you can access the multiple choice question anytime from 7 a.m. to 7 p.m. and I will keep it open for online so that you don't have to come for the class. And if there is any issue, let me know. Okay?
It's gonna be 1.5 hour for hands-on?
Hands-on is gonna be 1 hour 15 minutes.
50.
50,
And
50.
you shouldn't go to class, right?
Sorry?
You said it's gonna be online, you shouldn't come to class?
No, class hands-on exam is gonna be in person. So next class, you're gonna come to the class, okay? It's gonna be on Monday, and Monday I will tell you the guidelines for multiple choice questions, okay? Don't worry. So right now you're gonna come for the class, next session, for hands-on exam, okay? Bin is absent, right? Bing is present, Bing Shan is present, Javed is present, Ines is present, Jamie, Lee Jamie is absent, Kylie, Pam,